Okay, this is a second part to properties of exponents, and in this video I'm going to discuss two other properties that we have. And the third property is the product of power. And what this says pretty much is that if you have powers, um, if you're going to multiply powers with the same base or with same bases, just add the powers. And this is what it means. If you have a number raised to the power of m, and you're going to multiply that to that same number, we have the same base, and it's raised to the nth power. What you can do is just add the powers. So I'm going to add a plus m plus n. These are the powers, and I keep the same base. And this will be, let me give you two examples. The first example will be 3 to the power of 2 times 3 to the power of 6. Well, the rule says that if I have powers multiplying but they have the same base, I can keep the base the same and I can just add the powers. Well, 2 plus 6 is 8, so my answer will be 3 to the power of 8. Well, what if I don't have numbers, if all I have is letters? Here's another example. So example 2. Example 2. So if I have x raised to the power of 3 times x raised to the power of 7, the rule says that I keep the base the same. Notice that both of them have the same base. So I will have x raised to the power of 3 plus 7, because the rule says that I can add the powers. So I end up with x raised to the power of 10. And this will be my final answer. I guess I'm going to throw a different example because people tend to get confused. What if the bases are not the same? For example, x raised to the power of 3 times y raised to the power of 5. Well, because I have different bases, in the first term I have an x, and on my second term I have a y as my base. Well, I will just leave this as x to the power of 3 y times y to the power of 5, and this will actually finalize my answer. Let me jump very quickly to my second property. That means that is a quotient of powers property. And what this says is that if I have exponents dividing each other with the same base, I can just subtract the exponents. So if I have a number a raised to the m power, or to the power of m, I keep saying it backwards, a raised to the power of m over a raised to the power of n, I can keep the base the same, keep the same base, and I can subtract the powers. So here are two examples. Example number 1. Example number 1. Let me move this a little bit. Okay, example number 1. Say that I have 3 raised to the power of 6 over 3 raised to the power of 4. Well, because I have the same base, I can subtract the powers. So this will lead me to 3 to the power of 6 minus 4, which is just 3 to the second power. Well, what if it was backwards? Let's see if it was backwards. So here's another example. Say I have 3 raised to the power of 4 over 3 raised to the power of 6. Well, this is equal to 3 raised to the power of 4 minus 6, which is equal to 3 raised to the power of negative 2. But wait a second, I cannot have negative powers. I can't have this. This is an incomplete answer. In order to make this power positive, I will need to do the reciprocal of 3 to the power of 2, which is just 1 over 3 to the power of 2. And this will finalize my answer. Make sure that you don't leave your answers with negative exponents. And I explained this in one of my previous videos. Let me do one more example. one more example, and in this one I'm going to use variables. Okay, so say that I have x to the power of 10 over x to the power of 4. Because I have the same base, I will apply this rule or this property which says that I can subtract the powers. So x to the power of 10 over x to the power of 4 is just x to the power of 10 minus 4, which is equal to x to the power of 6. And that finalizes my answer.